Dr. V. Anitha Rani, Associate Professor of Chemistry from Institute of Aeronautical Engineering. So today we are going to discuss about energy resources. So in that we are going to discuss renewable and non-renewable energy resources. So in energy resources, renewable energy resources, we are going to discuss about solar energy, wind energy, geothermal energy, hydropower energy. And non-renewable energy resources, so we are going to discuss about coal, petroleum and natural gas. So classification of energy resources, the sources of energy, so there are two types, primary source, secondary source. So primary source is renewable energy and non-renewable energy. So renewable energy, it is also called non-conventional energy. Non-renewable energy, it is also called conventional energy. So in renewable energy, so we can take the here examples, we can take hydropower energy, solar energy, wind energy, geothermal energy and biomass energy. In non-renewable energy resources, we can take example coal, petroleum, natural gas. So energy resources, the term energy means capacity to do work. So energy can neither be created nor destroyed but transformed from one form to another form. So energy is closely that is related to force. So when a force causes an object to move, energy is being transferred from the force to kinetic energy. So energy is present in a number of forms such as mechanical, thermal, chemical, biological energy. So energy is present in number of forms such as mechanical energy, thermal energy, chemical energy, biological energy. So energy production and utilization have become essential to carry out many activities in modern life. So energy is one of the important requirements that a country needs for its economic growth. So at the same time, energy production has its impact on environment due to pollution and finally affects the quality of life of people. So energy is one of the most important requirements so that a country needs for its economic growth. But at the same time, the energy production has its impact on environment due to pollution. And finally, it affects the quality of life of the people. So the energy, it is used for the like a cooking, heating, lighting and transporting people and goods by means of vehicles, manufacturing consumer goods and equipment, conversion of fuel into the other forms of energy for various purposes. For example, burning of coal to produce electrical energy or mechanical energy, and chemical to electrical by dry cell batteries. By dry cell batteries. So we use dry cell, that is primary battery. So where chemical energy converts into electrical energy, and using water in dams to produce electricity through mechanical energy. So using water in dams to produce electricity through mechanical energy. So all these here where we can use the energy for our utilization in day-to-day life. So the energy resources, the power generation capacity in the country has increased from 1400 megawatts at the end of 1947. So to 92,894 megawatts at the end of that is 1999. So for various sectors we can take hydropower sector, thermal sector, nuclear sector, wind sector. So for example, hydropower sector, so here it is what we are getting the energy sources, the energy production is 22,438 megawatts, and thermal sector 67,618 megawatts, and nuclear sector 1,870 megawatts, and wind sector 968 megawatts. So this is according to the that we got the records in 1999, but we are in now 2021. So 2021 means we can estimate it is like we are getting more energy power, more energy production by this by this like hydropower sector, thermal sector, nuclear sector and wind sector. So renewable energy, so those sources of energy which are inexhaustible and can be regenerated again and again are called a renewable source of energy. So already we discussed about renewable and non-renewable energy resources. So example we can take here in renewable energy sources: solar energy, wind energy, ocean energy and geothermal energy, biomass energy, hydropower energy. All these are called renewable energy resources. Non-renewable energy resources means those sources of energy which are exhaustible and cannot be regenerated again and again. Cannot be regenerated again and again are called non-renewable sources of energy. So, for example, we can take coal, petroleum, natural gas. So, these are the examples of non-renewable energy resources. And harvesting or harnessing of energy, the process of collecting, converting and using of energy, the process of collecting, converting and using of energy is known as harvesting of energy. So we are going to discuss now renewable energy resources. So we know already examples: solar energy, wind energy, geothermal energy, biomass energy, hydropower energy. So we have to know about what is solar energy and what is wind energy, what is geothermal energy and what is hydropower energy. So solar energy, it is the technology used to harness the sun's energy and make it usable. So we get the energy from the sun, we get the heat from the sun, so that we will collect and will convert into electrical energy. So the energy which is derived from the sun is known as solar energy. The energy which is derived from the sun is known as solar energy. So we can take here we can see in this diagram. So we are using solar cells. We are using solar cells and the heat from the sun. Okay, so that we are taking in solar cells and we are converting. We are converting into electrical energy. So using the sun's energy, so we are generating the electricity. So it can be used to for direct heating or sun's heat. It is converting into electricity. So many people are familiar with so-called photovoltaic cells. Photovoltaic cells are solar panels. So found on things like spacecraft, rooftops, so handled calculators. So in all these, we will use the solar energy, spacecraft, rooftops, and handled calculators. So where we are using the here solar energy. So we are using solar panels. So in these applications. So we can see in this diagram, okay, so the people are using on rooftops, that is solar panels. So to convert the solar heat into electrical energy. So the cells are made of semiconductor materials like those found in computer chips. Okay, so what are the materials we use in solar energy? So we will use solar cells. The solar cells, what it is made up of? It is made up of semiconductor materials. What are the semiconductors materials we are going to use? We will use the silicon material we will use. Silicon material we will use. So in solar cells. So when sunlight hits the cells, it knocks the electrons. It knocks the electrons, loses from their atoms, as the electrons after hitting the electrons, it loses from their atoms. So these electrons, it flows through the cell, and then generating the electricity. So photovoltaic cells convert direct solar energy into electricity. So we can see in this diagram, we can see here the solar cell. We can see N-type silicon, and P-type silicon. We are taking N-type silicon, P-type silicon. So when the solar heat, okay, so when the sunlight that is hitting this cell, when the sunlight is hitting this cell, so what happens? So the electrons that is losing from the atoms are losing electrons, okay, from the cell. So that electrons, it flows, okay, when the electron is flowing, then electricity will be produced. When the electron is flowing, So electricity will be produced. So we can see here the electron is flowing. Okay. So when the electron is flowing, so electricity will be produced. So but the major problem with the solar energy is the during cloudy weather, it is available in less quantity than on sunny days. On sunny days we get more electricity production, but on cloudy days we does not get electricity production that much on sunny days. So we can see in this diagram very clearly the electron flowing from here. We can see in this diagram. So p-type semiconductor, okay, and here n-type semiconductor, and electron is flowing from p-type semiconductor to p-type semiconductor to here it is flowing. The current is flowing from n-type semiconductor to p-type semiconductor. So the we can see clearly, very clearly, we can see how the current is flowing. Okay, how the electron is flowing from p-type semiconductor to n-type semiconductor. So this is a solar cells. So what we are taking here is it is composed of two layers of semiconductor material with opposite charges. With opposite charges means we are taking here p-type semiconductor and n-type semiconductor with opposite charges. So when the sunlight is hitting the surface of the cell, it knocks the electrons loose. Means the atoms loses the silicon atom. It loses electrons, which then travel through the circuit where we are arranging the circuit. It travels through the circuit from one layer to the other layer, from one layer to the other layer. So providing the flow of electricity. So we can see in this diagram very clearly the flow of electrons from the n-type semiconductor to p-type semiconductor. So n-type semiconductor we know already there will be one extra electron will be there. Okay. So from that n-type semiconductor, the electron is flowing from n-type semiconductor to p-type semiconductor. So that flow of electrons is called nothing but flow of electricity. Flow of electricity. So the advantages are big windows placed on the sunny side of the building allow sunlight to heat absorbent materials on the floor and walls. These surfaces then release the heat at night to keep the building warm. So to keep the building warm, we are using the solar cells, means we are utilizing the solar energy. Absorbent plates on a roof can heat liquid in tubes that supply a house with the hot water. So we are getting hot water because we are using in our house on the roof of the tops. We are arranging the solar panels and we are converting the sun's heat. Okay, we are converting into electricity. So solar energy is inexhaustible fuel source that is noise free and pollution free. So the technology here is also versatile. Hence, solar cells generate energy for far out places like satellites in Earth orbit and cabins deep in the Rocky Mountains. So we can use the solar energy so in satellites and also deep in the Rocky Mountains. So the other advantages are electronic calculators, watches, and here we can take so good advantage we can discuss available for free of cost, and here the solar thermal power plants so that employ various techniques to concentrate the sun's energy as a heat source. So the heat is then used to boil water to drive a steam turbine that generates electricity. So when the turbines are moving, so then generation of electricity will be taking place. So in this way, here we are using the solar energy so to produce electricity. So what are the disadvantages of solar energies? Solar energy does not work at night. So without a storage device such as a battery, hence it does not work at night. Okay, when there is a sun is there, okay, sunny days only. So we are getting the solar energy. So that is we can produce the electricity. So cloudy weather can make the technology unreliable during the day. So if the weather is very cloudy, so we cannot get here solar energy, means we cannot produce electricity. And here the the requirements a lot of land area to collect the sun's energy at rates useful to lots of people. Okay, we require lot of land area also so to produce here solar energy. So next is wind energy. So we completed solar energy. Next is wind energy. Wind energy is the kinetic energy associated with the movement of atmospheric air. So windmills convert the wind energy into electrical energy. So we are arranging the windmills so we can convert the wind energy into electrical energy. So the efficiency of windmill is increased with the speed of wind and the length of rotor blade. Okay, the speed of the wind we are increasing and the length of the based on length of the rotor blade, so we can increase the efficiency of the wind so that we can get more production of electrical energy. So the total wind energy potential in India estimates that 25,000 megawatts. So wind energy is a source of renewable power which comes from the air current flowing across the earth's surface. So we can see in this diagram how we are arranging the windmills here in this field of the land. So we are arranging the windmills. So turbines. So what we are arranging the wind turbines harvest this kinetic energy and convert into usable power, so which can provide electricity for domestic, industrial and agricultural sectors. So we can use for domestic purpose, industrial purpose and agricultural purpose. So this wind energy. So we can see in this diagram, so we can observe very clearly the wind passes over the blades and makes them turn. So we are passing the wind over the blades. So the blades turn a shaft. We can see the shaft here. Okay. So the blades turn a shaft within the, we can see here the box at the top of the turbine. The box at the top of the turbine. So in this we will arrange the shaft. Okay. So shaft will be, okay, the blades, it is turning the shaft. Okay, it is turning the shaft. The shaft turns a generator which converts kinetic energy into electrical energy. So in this only we are arranging the generator. We can see here it is the generator. Okay, so here that conversion of kinetic energy into electrical energy, it is taking place in the generator. Then transformer, we can see the transformer here. So a transformer converts the electricity to the right voltage for the local network. Okay, we have to arrange the transformer. So then now it will convert here into right voltage, and we can pass that current into the we can pass for houses, okay, or for agriculture purpose. So the electricity is exported to the electricity grid. Okay, so this is the diagram we can observe here very clearly about the working of wind energy. So here we can see in this diagram very clearly, wind turns the turbine blades. And here spinning of the shaft. We can see here spinning of the shaft, generating electricity where in generator, and inverter converts electricity from DC to AC. So here we can see the inverter converting from DC source to AC source. Okay, direct current to alternate current. Okay, electricity is connected directly to the manpower. Okay, so we can see in this diagram directly we are passing electricity to the houses, or connected to the battery bank, or connected to the electricity. So what are the advantages means here wind energy, it is one of the fast growing sources of new electricity generation in the world today. These growth trends can be linked to the multi-dimensional benefits associated with the wind energy. So the electricity produced from the wind power is said to be eco-friendly because its generation produces no pollution, no greenhouse gases, no pollution and or no greenhouse gases. So it is good for health and environmental safe, available for free of cost. So wind is a renewable energy source. Okay, so we can produce electricity from the wind energy. So disadvantages is it generates noise pollution. As the blades are moving, we get more sound. Okay, generates noise pollution. And here wind energy, the windmill kills the birds. Sometimes when the birds, okay, that is flying, the windmill kills the birds. Okay, so these are the some of the here disadvantages of the wind energy. And geothermal energy, we can see the name itself, geo means earth and therm means heat. Geo means earth and therm means heat. So geothermal energy comes from heat produced by the earth. Geothermal energy comes from the heat produced by the earth. Produced by the earth means from the earth we are getting the heat. We are utilizing that heat and producing electricity. So geothermal energy found within rock formations. So beneath the surface of the earth, there are a number of heat producing layers of rock. Minerals, and including we can take inner core. Okay, so the deeper you dig towards the center of the earth, the hotter it gets. The deeper you dig towards the center of the earth, the hotter it gets. So there will be more temperature. So in underneath means when we are digging deeper into the earth, so there will be more heat. So we can collect that heat, we can produce electricity. So here geysers, we can see in this diagram geysers. So geysers, a natural spring that emits hot water. A natural spring that emits hot water. We can see in this diagram, geyser. Okay. So and hot springs are examples for geothermal energy, where steam and hot water comes to the surface. We can see here the hot water comes to the surface. So geothermal water in the arrow mark we can observe in the diagram. So where the hot water it comes out. So hot water comes to the surface in areas where the steam is tapped by drilling. So we have to give drilling here. We have to dig deeply. Okay. So when we are going for drilling, we can collect the hot water. So the obtained steam is then used to generate the power. So from that hot water, we will produce the steam. By producing the steam, we can generate the electricity. So geothermal power plants also harness the heat of the earth through hot water and steam. Okay. In these plants, heat is used to generate electricity by rotation of turbines. We can see the working of here geothermal power plant. So here we are collecting the hot water. In this diagram, we can observe very clearly. So we are collecting the hot water from under the earth. Okay, we can collect the hot water. So we can collect the steam. We can convert into steam, and where that steam we are passing through the generator where the turbine blades are there. So by rotating the turbine blades, okay, so then we can produce the heat that we are passing into the generator. Okay, that we are passing into the generator, where here we can convert into electrical energy, and we are passing that to the transformer and to the specific locations, and we are collecting the cooling water. Again, we are passing into the underground. So we can observe in this diagram very clearly how geothermal power plant works, how we are collecting hot water and converting into electrical energy. Okay, so in these plants, heat is used to generate electricity by rotation of turbines with a hot steam gush out through the pipe. So we can say the core, about 4,000 miles beneath the surface, can reach the temperature of 4,200 degrees centigrade. The temperature gradient in Earth anatomy can be used for the production of electricity. This heat, which can be harnessed for energy, is caused by residual heat from the formation of the Earth, as well as decay of radioactive isotope. Okay, so how we are getting that much heat means by the decay of radioactive isotopes. So we can observe very clearly how the working of geothermal power plant. We are collecting hot water, converting into steam, and we are allowing that steam into here generator, where conversion of electrical energy taking place. So that electricity we are passing into the transformer. Then from there we are passing into the specific locations. So advantages are, it is a good, one of the best renewable source of energy nowadays. It is non-polluting and environment friendly. So there is no wastage or generation of byproducts. So geothermal energy can be used directly. In ancient times, people used this source of energy for heating homes and cooking purpose. So maintenance cost of geothermal power plants is very less. So geothermal power plants don't occupy too much space and thus helps in protecting natural environment. Okay. So unlike solar energy, it is not dependent on weather conditions. So these are the advantages of geothermal energy. Disadvantages are only few sites have the potential of geothermal energy. Most of the sites where geothermal energy is produced are far from the markets or cities where it needed to be consumed. Total generation potential of this source is too small, so there is always a danger of eruption of volcano. Okay, that is definitely it happens. Installation cost of steam power plant is very high. There is no guarantee that the amount of energy which is produced will justify the capital expenditure and operation cost. It may release some harmful poisonous gases that can escape through the holes drilled during construction. Earthquake also cause damage to the plants. Sometimes we get the earthquakes also. So all these are disadvantages of geothermal energy. Now next is hydroelectric energy. So electrical power is generated by hydroelectric projects in which dams are constructed across the river. So we can see in this diagram, so where we have constructed a dam, across the river, where we have constructed a dam across the river. So the kinetic energy of water is converted into mechanical energy by means of the turbines, and in turn the mechanical energy is transformed into electrical energy by generators. So hydroelectric power or hydroelectricity is basically electrical energy that has been generated using natural forces such as gravity or flowing water. So it's usually produced by dams because dams can store and direct they can store large volume of water. So hydroelectric power is becoming increasingly popular. So we are producing more electricity by hydroelectric energy, hydroelectric power. So we can see in this diagram how here hydroelectric power system it is working. Dams here it is generating electricity because they contain a special mechanism designed to take energy in flowing water and turned into electrical energy. So here a power source is used to spin a turbine, basically a propeller, which in turn spins the metal shaft. So we are arranging here turbines, okay, and forming the equivalent of electrical generator that produces and stores electricity. So we can see here. So we are taking from the dam where we are storing the water. We will take the water flow, and here turbine blades are there. Here turbine we can see. So by the movement of turbine blades, it will convert into mechanical energy. Then we are passing in. We are arranging here generator where conversion of this mechanical energy into electrical energy. Then that electrical energy we are passing into the transformer. We can see here, and then we can collect electricity, okay, and we can pass into the specific locations. So we can see in this diagram very clearly, okay, how hydropower plant that is working to generate electricity. So advantages are hydropower is here it is a clean fuel source, and it does not pollute the air like power plants that burn. Hydropower is a domestic source of energy, mostly produced here in the United States. Here hydropower plant it is benefit. What are the benefit means? We are getting a clean electricity. And disadvantages are fish populations can be impacted if fish cannot migrate from one place to another place. Hydropower can impact water quality and flow, and hydropower plants can cause low dissolved oxygen levels in the water. And when water is not available, the hydropower plants cannot produce electricity. New hydropower facilities impact the local environment and may compete with other use for the land. So humans, flora and fauna may lose their natural habitat because for the constructing the dams, so we need a large area of the land. So when we take the large area of the land, we may lose the animals and plants and biodiversity. So these are the disadvantages of hydropower energy. And non-renewable energy resources. So renewable energy resources, we discussed about solar energy, wind energy, and we discussed hydropower energy, geothermal energy. So non-renewable energy resources are, we can take the example here, coal, crude oil, and natural gas. So first of all, these are called fossil fuels. We will take as a fossil fuels. Fossil means the remains of the animal or plant which have become hard and turned into rock. Okay, so by the decay of the animals or plants, okay, the remains of the animal and plants, so this will be converting into like a rock formation. So it is called like a solids, okay, or semi-solids like. So it is called fossil fuels. Why it is called fossil means it is formed by the remains of the animals and plants. Remains of the animals and plants. So it is called fossil fuels. So all these formed in the earth crust, which have been formed in the past by the geological process. So fossil fuels are, for example, we can take solid coal and liquid like a crude oil, example crude oil or petroleum, and gas is a natural gas. So in this diagram we can see natural gas, coal and petroleum. So first of all, coal, here we have to discuss solid fuel. Coal is a fossil fuel which occurs in the layers of earth crust. So coal is a combustible black or brownish black sedimentary rock formed as a rock strata called coal seams. So coal is mostly carbon with a variable amount of other elements, hydrogen, sulfur, oxygen and nitrogen. So coal is a combustible black or brownish black sedimentary rock. So what is the main here? What is the main here present in the coal is carbon is the main element present in the coal, and the other elements are hydrogen, sulfur, oxygen, and nitrogen. So this is the coal what we are collecting from under the earth crust. So because of the environmental hazards, so trees were buried inside the earth by the action of temperature, pressure and bacterial actions over the period of thousands of years or million of years. So converting. So this like plants or animals. So that will be here in the presence of temperature and pressure and bactericidal action. So that will be converting into coal. Converted into brown, black, solid. That is named coal. So we can write here wood. Okay, decay of the plants. So under heat. Okay, temperature or heat. Okay, so pressure, under pressure and bactericidal action. Okay, so the wood is converting into coal, taking million years. Million years to form coal, like 300 to 400 million years. So coal is one of the major source of energy in many industries such as steel industry, cement, paper industry. So we are using coal in iron industry. Okay, so coal is extracted by the process of mining. So here it is involves accidents due to mine collapse and groundwater pollution and accumulation of poisonous material, explosive gases, etc. causes diseases. And CO2 pollution leads to greenhouse effect. So coal is extracted by the process of mining and involves accidents due to mine collapse, groundwater pollution, accumulation of poisonous material and explosive gases. So all these are like a disadvantages when we are extracting the coal. So next is crude oil. It is also called petroleum. So petroleum, it is one of the best primary liquid fuel. It is also known as crude oil. So the word petroleum means rock oil. Petra means rock, oleum means oil. So petroleum is dark brown viscous liquid. We can see here petroleum or crude oil. Crude oil. Petroleum is a mineral found deep in the earth crust. It is a mixture of number of hydrocarbons. So what is present means paraffins, alkanes, alkenes, aromatics and naphthalics. And nitrogen, sulfur and oxygen, these are also present but a very small percentages. And heavy metals like iron, cobalt, nickel also present in the petroleum but very small percentage. So the unpleasant odor of petroleum is due to the presence of some foul smelling sulfur compounds. So why we are getting the smelling of petroleum? Why we unpleasant smell means because of the presence of sulfur compounds. So we can see here mining process where we are collecting. Okay, where we can see here collecting petroleum. We have to dig the pipe under the sea. So layers will be there. So here we can see a brine. Here also brine water. So this is rock area. Okay. So under the sea. So where the touching of the rock. On the top of that brine water will be there. Salt water. Again on the top we can see the oil, petroleum formation. On the top of that we can see gas, that is natural gas. Natural gas also we are collecting. So we are taking the two pipes and digging. So from one pipe we are collecting the natural gas in that well. From another pipe we are collecting the petroleum. So we can see this is the impervious rock. Okay, so this is also rock. So like this, under the sea. So it is formed in the layers, means where the rocks are there. So in that rock area, so petroleum or crude oil will be so formed, and also natural gas. So this crude oil we are taking and heating up to 400 degrees centigrade in the oil refinery, and condense the vapors of hydrocarbons, and petrol and other petroleum products are refined fuels from the crude oil. So we are going for fractional distillation process, and we are getting the petrol, kerosene, diesel and fuel oil. Okay, according to their temperature ranges we will collect the petrol, diesel, kerosene. So these are main liquid fuels. So these are called secondary liquid fuels, which we are deriving from the petroleum or crude oil. So these fuels are used for domestic work and for auto vehicles and power generation. So petroleum products are used in large quantities in manufacture of detergents, plastics, fertilizers, pharmaceuticals, synthetic rubber. So these are the applications of crude oil. Now last one is natural gas and non-renewable resource. So we discussed about coal and crude oil, and last one is natural gas. So gas deposits are trapped from the sedimentary formations by means of drilling holes in the rock formations. So already we discussed in crude oil, okay, how we are collecting the crude oil. So when we are collecting the crude oil itself, we are inserting one more pipe and we are collecting the natural gas when we are going for mining of the petroleum. So the natural gas is obtained from the wells dug in the earth during mining of petroleum. It is mainly composed of methane and small quantities of ethane along with the other hydrocarbons. So it is mainly the main composition of natural gas is methane. So while we are burning the natural gas, the emission of CO2 is less. So that reduces greenhouse effect and global warming. So here a total of 734 billion cubic meters of gas is estimated as proven reserves. Okay, it is an excellent domestic fuel which can be conveyed through pipelines to longer distance. So we are utilizing the natural gas, and we are for domestic purpose also we use the natural gas. We can pass that natural gas for the longer distances. A large number of chemicals are synthesized from natural gas. So we can synthesize ammonia from the natural gas. It is also used as a raw material for the manufacture of carbon black, so which is used as a filler for rubber. It is used as a filler for rubber carbon black, so which we can improve the hardness of the rubber. And hydrogen is used in the synthesis of ammonia. So we can synthesize the ammonia, we can use the hydrogen from natural gas. So methane on microbiological fermentation process, okay, so that gives synthetic proteins. So we can now we can prepare synthetic proteins from methane, so which are used for animals, which are used as an animal feed. So these are the applications of the natural gas. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.